Just a quick review of just a phenomenal thing from the book. So we know that this right here represents an antiderivative f of x. And we know if we take the derivative of the antiderivative, if we look for f prime of x, that leads us to our function f of x. So what we're saying is that the integral is an antiderivative of f. And we can do a little bit of algebra and kind of mess with that a little bit. Because if we know that the antiderivative, the integral is the same as the antiderivative plus c, some constant, then we can say that the integral from a to a of any function is an antiderivative of a plus c. Well, we know that from a to a is equal to 0. So we know that f of a, the integral of a plus c, is equal to 0. So it means that the negative integral of a, so I'm just subtracting f of a from both sides, is equal to c. Well, if I kind of go back to this formulation right here, then I can see that the integral is equal to f of x, and instead of plus c, I put minus f of a. So this is an amazing discovery here, because what it's saying is that if I can evaluate the antiderivative for x and subtract from that the antiderivative value at a, I get the value of the integral. Now I know it just seems like an algebra trick right in here, and I guess in a way that it is, but it works, and it's what we're going to use. So let's try a couple of problems. I would like to evaluate this integral. I want to know what is the area under the curve cosine x between 0 and pi over 2. Well, I'm going to go back to here, say, oh, well, I know that the integral is going to be equal to the antiderivative evaluated at the upper limit of integration minus the antiderivative evaluated at the lower limit of integration. So I think I'm even going to write that down right here. I'm going to write big F of x minus big F of a. This here being our a, and this here being our x. Well, the antiderivative of cosine x, I think that's sine x, isn't it? So I would have sine of pi over 2 minus sine of 0. Well, this gives me sine of pi over 2 is 0. No, take that back. And sine of pi over 2 is 1. Sine over pi over 2 is 1. Sine of 0 is 0. The answer to this should be 1. Let's test it on our calculator, just to be sure. Alpha, F2, number 4. I want to go from 0 to pi over 2. And the function I want to use is cosine x dx. Enter. The answer is 1, just what we got. How about that? How about we try this one? Well, again, I know that it's going to be big F of x minus big F of a. The question is, what is big F of x? Well, that's equal to, oh, this looks like x cubed. x cubed is the antiderivative of 3x squared. I just kind of recognize it. I could do the whole placeholder thing, but I'm sure that it's x cubed. So if I want to evaluate this this expression, this antiderivative here, well, I'm going to go. I'm sorry, not x. I'm going to evaluate. I'm going to do like this. I'm going to go f, big F of 2 minus big F of -1. So that's going to give me 2 cubed minus -1 cubed. So that should give me 8. Well, -1 cubed is -1 minus that, so plus 1. My answer should be 9. Let's find out. Let's test it on the calculator. Alpha F2, number 4. I'm going from -1 to 2 of the function 3x squared dx. Enter, and I get the number 9. Not so tough. In fact, it's really pretty amazing.